This is Physics 241 Lab. Today's Lab 10. It's on pendulum periods. And I guess to start off, we'll define what a pendulum is and what a period is. A pendulum is any sort of an object of some mass hung on a string, which is suspended on a pivot, and it's pulled back a certain angle, and it's allowed to swing back and forth. If you look here, we have a mass hanging down with a arm length of the pendulum, and it's pulled back a certain angle. It's called the amplitude angle. And when we pull the mass back to this position, we let it swing this way, and then we let it swing back. And that back and forth period is called the period, which is abbreviated T, and it's measured in seconds. So the period is how long it takes for the mass at this angle, this arm length, with this mass to swing all the way here and all the way back. Now, in working with this lab, there are going to be a few variables. The variables are going to be the amplitude angle theta, how far we pull it back, the mass of the object m, how much it weighs, and the arm length L, how long an arm the pendulum has. And we can vary all three of these and find out what's the effect on the period. Does amplitude angle affect the period? Does the mass of the object affect the period? Does the arm length affect the period? What we're going to do is we're going to measure the period with a photo gate. We talked about the photo gate before, and a computer hookup. And the photo gate itself will feed into the computer, and it will read out the period in seconds. Now, in our first variable, we're going to vary the amplitude angle. And that's this angle right here. We'll pull the weight back and let it swing. In this instance, we have a constant mass of 200 grams and a constant arm length of 45 centimeters. But we varied the amplitude angle. First it was 10 degrees, then 20 degrees, then 30 degrees. In all three instances, the period is 1.4 seconds. In other words, it takes 1.4 seconds for a 200 gram weight with a 45 centimeter pendulum arm pulled back at pretty much any angle to swing back and forth. 1.4 seconds. It doesn't matter what this angle is. If we varied the mass, we used three different iterations. First 200 grams, then 70 grams, and then 20 grams. We had a constant angle of 10 degrees and a constant arm length of 45 centimeters. And in this instance, again, it did not matter what the mass was. The period was still 1.4 seconds, same as in the first instance. Finally, we varied the arm length, this L. We varied it from 45 centimeters to 10 centimeters. And we measured the period. And as you can see, as the arm length decreased, the period decreased as well, which kind of makes sense. The shorter this arm is, the less time it takes to swing back and forth. Well, we've also determined from this that only the arm length affects the period. The mass didn't, the amplitude angle didn't, only the length of the arm. And again, as the arm got shorter, the period got shorter. Finally, we compared our measured T, which we just talked about, to our calculated T. The formula for period in seconds, period equals 2 pi times the square root of the arm length over gravity. So our arm length in meters, now remember we originally said 45 centimeters. 45 centimeters is 0.45 meters. The arm length is in this column. We came up with a time measurement, a period measurement in this column. And then we put this arm length into here, this L, 0.4, 0.3, 0.2, 0.1, G, 9.8 meters per second squared. And we calculated the period. And the calculated period, as you can see, is very close to our measured period. We have a very small error, a little bit more at the shorter arm length. But in any event, the whole purpose of the lab was to show that for pendulums, the arm length is the important variable. The mass and the amplitude angle are not. And in this particular lab, following this equation, our calculated period and our measured period were very close.